When you're solving math problems, you must have a spirit of skepticism. For example, with this problem, even after I finished it, I was still doubting whether I did it right. Let's take a look. It's definitely very difficult to solve for x in this equation. What comes to mind is the method of raising or lowering the degree, right? If we raise x to the 6th power by 1 degree, doesn't it become x to the 7th power, right? So let's try multiplying both sides by x and see what happens. Multiply both sides by x. Now we have an x to the 7th power, right? And x to the 5th becomes x to the 6th, doesn't it? X to the 4th becomes x to the 5th, right? The cubic term becomes quartic, right? The quadratic term becomes cubic. The linear term becomes quadratic. Does the constant term become linear? Well, that's 0, right? Be careful with the signs. Don't get them wrong. For the second step, be careful. Negative, positive, negative, positive, negative, positive, negative, positive, no problem. So what is x to the 7th power equal to? Since we're solving for x to the 7th, move everything over, move it all to the right side. It becomes positive, right? Positive x to the 6th, negative x to the 5th. What is this? This negative becomes positive, right? And the positive becomes negative. Be careful not to mix up the signs here. The positive becomes negative, right? So x to the 7th power equals this whole big expression. If you compare this whole big expression with the original, do you notice something? They look exactly the same. Look, the 6th power, 5th power, 4th power, 3rd power, the signs are all correct. So x to the 7th power is equal to this. So can I just replace this whole expression with x to the 7th power? X to the 7th power plus 1 equals 0. So x to the 7th power must be negative 1, right? So is there any problem? Isn't x to the 7th power equal to negative 1? Now here's the question. If x to the 7th power equals negative 1, can I deduce that x equals negative 1? Is x equal to negative 1? If you substitute x equals negative 1 into this equation, let's see if it works. If x equals negative 1, plug it in and it becomes positive 1. Plug negative 1 into this term, it's also positive 1, still positive 1, still positive 1. Each time you substitute negative 1, it's positive 1. So it's 1 plus 1 plus 1 plus 1. What does that equal? It equals 7. It's not equal to 0. So that means x is not equal to negative 1. But you calculated that x to the 7th power equals negative 1. Is that correct? I thought about it carefully. And is it possible that x to the 7th power equals negative 1 is indeed fine? This step should be fine. It should have 7 roots, everyone. It should have 7 roots. One of the roots is negative 1, and there are 6 other roots. There are still 6 other roots. These 6 roots, meaning that if you substitute negative 1 as a root, it doesn't work. That's an extraneous root, an additional root of the equation. These 6 roots should work if you substitute them in, but what do these 6 roots look like? Most likely, I think they should be complex numbers. Maybe there are no real roots, or maybe there are real roots. I don't know. I really don't know what these 6 roots specifically look like. But what I do know is that for these 6 roots, their 7th power equals negative 1. That's correct, right? So honestly, this problem feels a bit strange or unusual to me. Does anyone here understand it clearly? Can someone please verify or confirm if what I'm saying is actually correct?